Okay, this is example 4. And example 4 is a classic example of a ladder leaning against the building, which you will probably see often in related rates. So let's start by looking at some of the information that we're given. We start by telling that this ladder is 16 feet tall and that it's being pulled away from the wall. When t equals 0, it's 5 feet from the wall, and it slides away at 3 feet per second. So since they've called this quantity x, let's go ahead and call that quantity x. And what this means is it's being pulled in this direction at 3 feet per second. So from what we know, we can call that dx dt is equal to 3 feet per second. So that's the first quantity that we know. They want us to find the velocity of the top of the ladder. So the velocity is how fast the ladder is moving down the wall. It is the rate of change of y. So what they want us to find is dy dt. And they want us to know that when t equals 1. So we have to ask ourselves, when t equals 1, how far is it from the wall? Well, we're told that when t is 0, x is 5. And if it's moving 3 feet per second, when t is 1, then it will become 8 feet because it's moving 3 feet every second. So when t is 0, it's 5. When t is 1, it's 8. And that's the quantity that we're looking for. So we're trying to find dy dt when x is equal to 8. So we have to ask ourselves, what relationship do we know that can relate these pieces of data? We know that this is a right triangle. So let's use our handy-dandy Pythagorean theorem. In this case, I'm going to say x squared plus y squared. And let's go ahead and call this quantity z. It's equal to z squared. Standard Pythagorean theorem. Since we need to know dx dt and dy dt, it's probably helpful to take the derivative of this with respect to t. So using the power rule, I get 2x, and then using implicit dx dt plus 2y, using the power rule, and then using implicit dy dt is equal to 2z dz dt. Again, using power rule and implicit. Okay, so I need to know some quantities. I know x. X is 8. I know dx dt, that's 3. I'm trying to find dy dt. I don't know y. I don't know z, but I do know dz dt. How do I know dz dt? The length of this ladder is not changing as it moves down the wall. The length of this ladder stays 16, regardless to whether or not the ladder is here, or as it moves down, it remains 16 feet. So since the length of the ladder is not changing, dz dt is equal to 0. Because that length is not changing, dz dt is equal to 0. Okay? So if dz dt is equal to 0, that means that this whole thing is equal to 0. So now I only need to find y. And to find y, I can go here and use the Pythagorean theorem in putting in information I know. So using the Pythagorean theorem, I have 8 squared plus y squared is equal to 16 squared, which gives me y squared is equal to 256, I think, minus 64, 192. So y is equal to the square root of 192. All right, so I have everything I need to solve this. So to solve this, I'm going to evaluate for all the quantities that I have. So I have 2 times x, which is x is 8. dx dt is 3, plus 2 times y, which is the square root of 192, is equal to I missed something, times dy dt, and that's equal to 0. So I'm solving for dy dt, so I'm going to subtract this quantity from both sides. This would be 2448. So 2 square root of 192 dy dt is equal to 48. So dy dt is equal to 24 over the square root of 192. And my units for this would be feet per second. Also, this would be negative. And the reason it's negative because it's moving downward. So because it's moving downward, it would have a negative value. Okay? Now that was a little bit more complicated, but you might want to look at the examples again and make sure you understand that, and we will do another triangle problem in the next example. So please load example number 5.